combine the ones that don't have an X or a Y?
Okay. So, guys, you've been doing this in 6th grade. So, since the beginning of this school year for sure, right? You did this when you were doing systems of equations. All you're doing is combining your like terms, but you've got to get rid of your you've got to get rid of the parentheses first, right? So how do I get rid of this parentheses? What do I need to do? Multiply by -3, distribute it to everything there. So -3 times x is what? What's -3 times x, guys? -3x. -3 times 1? -3. Does this -3 change any of this? No. So plus 3x minus 2xy. Now, what are my like terms? -3x and positive 3x. And they actually cancel each other out. So my final answer for this is -2xy, because there's nothing else to do with that, -3, because I always list my variables, my terms that have variables in them first.
Oh, so I was right. I just didn't know how to do it. I was completely
The only thing that confused me was like, only thing
all I did was combine them and add them together.
So, on the next one, what are you going to do for this next one? Got to get rid of the parentheses first. It includes this -2. This negative goes with the 2. Or the minus goes with the 2, however you want to look at it. So -2 times x, -2x, -2 times y is. Does this change any of this over here? No. So we've got -7 minus 21y. Do I have any like terms I can combine?
-2x and -7.
Okay, -2x and -7x. Give me a -9x. Then I have -2y and -21y, which gives me a -23y. Now for this last one, I've got a variable in front of my parentheses. So it's a -x, and what happens when I do x times x?
It's just 1 times 1. So you get 1.
Well, it's x times x, and how do I rewrite x times x?
1 times 1 times 1. Because every x equals x to 10.
Right, it's the same thing multiplied by itself, so it's x squared. It just happens to be a -x squared. And then -x times y is a -x y. Then I still have these terms that were up here at the front. So plus 4xy plus 6x. Do I have any like terms?
-x, what is the 2 thing?
xy.
-xy plus 4xy.
There's no other x squared. That's the only x squared. So it's going to stay the same, and we're going to keep it listed first. Okay, so we've got -1xy plus 4xy gives me what?
5xy. 3xy. Wait, how'd you get? Oh, it's a negative.
Because that's a negative, right? So it's 4 minus 1. And then there's nothing else to add to this 6x, so it's just plus 6x. So I'll put a box around my final answers here so that you know which ones were my final answers. The rest were just work. Okay. So now for this next question. Right, it's going to be harder to read up on my board, but it's in front of you. Okay, so Suppose you wanted to make a number bigger. What operations could you use to make a number bigger? Look at the order of operations. Don't say anything. Just look at the order of operations and write down which ones would make things bigger. And then in the next one, it's asking you which operations would make numbers smaller. So write down what you think they are. And we will come back to it in just a second. I'm going to go get some other colors besides red and green up here. So somebody give me one operation that would make a number bigger. Multiplication.
Addition.
Okay, another one. Addition.
Oh, I just put the signs. We have to write out the word.
It makes it more clear, but. So what else is there anything else that would make numbers bigger? An operation?
No, dividing is smaller.
Okay, so division goes down here. For smaller. What other one would be for smaller?
Subtraction.
Okay. There's one more in each. So look at our list over there of the order of operations.
Parentheses and exponents.
Okay, so parentheses is just grouping, okay? So it's not an actual operation because if it is an operation, it's already listed as multiplication, right? So what's the other operation that's up there?
Exponents.
Exponents. That's going to make things bigger, right? And this is sometimes called powers. Okay? Exponents are powers. So there is one more here that makes things smaller. If division is the inverse of multiplication and subtraction is the inverse of addition, what's the inverse of exponents?
Square root.
So the square root, right? Or the cubed root, or the fourth root, whatever. Okay, so in general, we call this roots. Okay? So taking the root of something.
I'm surprised I knew that. You're pretty smart.
So now look at that. So look at your answers for this one. We're on C now. Okay, but it's referring us back to the list that we made for step A. What would be the most impactful way to make a number bigger? Of those three choices, which way is going to make the most impact?
Multiplication.
No, exponents.
Y'all think about it. See if y'all can get a consensus about which ones are going to make the most impact to make a number bigger. And then it says which one's going to be the least impact to make the numbers bigger.
Exponents will be the biggest and addition will be the least.
No, exponents, you
Exponents are like times that number.
Okay. So does everybody agree? So the most impactful way, so exponents would have most impact. And what did y'all say would have the least impact?
Addition.
Addition. So we had most impactful and least impactful. So in part D, it's asking you to look at B. So same question, but we're talking about numbers getting smaller. So of these three, which one's going to be the most impactful way to make a number smaller and the least impactful way to make a number smaller?
And subtraction.
Okay. So roots is most impactful. And subtraction is Least impactful. Does anybody need C still? Everybody get that one because I had it covered up. So now, underneath that a little bit further, it wants you to create a ladder or some steps here. And it's asking you to put them on this ladder from most impactful at the top to least impactful at the bottom. So if we're talking about the operations that make a number bigger, we're talking about these three again, right? So which order should they be put in? And the same thing over here with the smaller ones. These three, which order are you going to put them in? So take a few moments and decide which order you're going to put those in. So let's see, what was the most impactful for making a number bigger? Exponents. What would be the next? And then addition last. So what about the smaller? Roots, division. So turn to the top of the next page. And this page is asking you to look at these problems. So we're looking at these problems right here.
The coefficient is the number by itself, right?
The coefficient is the actual number that's in front of the variable, yes. Okay. So,
Remember that.
okay. When you are multiplying, okay, when you're multiplying exponents, okay, you are, to answer this first question here, okay, look at this problem number 1. What did they do to the coefficients? And Jolene just reminded us that the coefficients are the numbers that are in front of the variables, okay? So what did they do to the coefficients? And then what did they do to the exponents? Okay, so you're looking from this problem where they're multiplying the exponents to your final answer over here. And I want you to write down what you believe the pattern is. What do you notice? Something happens with the coefficients and something happens with the exponents. And I want you to take a moment and jot down your observations. This is just what you see. You're looking for a pattern. I will come around and give you a few moments, and then I'll come around to see how you are doing on this thinking. So it looked as I walked around the room that you were able to figure out what happened with the coefficients, right? So what happened with the coefficients? What happened with 2 and 4 to get 12?
They
Multiplied. So the coefficients multiplied. Okay. But my exponents, I had a 2 and a 4 on my y. What did I have to do to get a 6? Add, right? Because 2 plus 4 equals 6. How did we get the 3 on the x, though?
Oh, wait.
I only see a 2 over here.
Because there's an x by itself.
The x by itself has that invisible 1 there, right? That invisible exponent. So 1 plus 2 equals 3. So what do we do to the exponents? We add the exponents. Okay? So add exponents, right, and multiply coefficients. Okay, and you can have this worded any way you want to. I just was simplifying it up here on my paper. So now look at question B. Since you did question A, look at question B. It says, what did they do with the fraction 5/10? This is also the coefficients here. Okay. So what did they do in this problem when we're dividing now? What did they do with the coefficients and what did they do with the exponents in this one? See if you can figure out the pattern there.
They divided the coefficients.
Okay. So let everybody have a second to see if they can figure out what happened with the exponents. Don't say anything out loud just yet. So we already said that the coefficients were divided. We're trying to figure out what happened with the exponents now. So if you look here, we've got an x to the 2 and an x to the 4. What are we left with over here? X2. So what happened? It's subtracted. Okay. What about over here? 5 and 2 for the y's? They subtracted as well. Became 3. And then what did we have on the z here? A 1 and 1 and 7. So our exponents were subtracted when we were dividing. So the next question says, why do you think some variables ended up in the numerator and others ended up in the denominator? Well, the numerator is the top of the fraction, right? And the denominator is the bottom of the fraction. So if we're doing the same operation, why did some end up on top and some end up on bottom?
Because they're dividing that as two different. Like you have to solve one. You have to solve both of them and then divide it.
We're not solving anything. We're only simplifying things. So, well, let's look. It also applied to this, the coefficients, right? 5 and 10. Why did the 2 end up in bottom?
Because
It's simplified to that, but why?
we're supposed to I'm sorry, ask the question again.
So why did the 2 end up on bottom of my fraction bar instead of on top? I had numbers on both top and bottom, so why did my number end up on bottom?
You call me slow.
Okay, well, look, let's see. Let's see if we can see a pattern. Okay, so we've got an x on top and an x on bottom. Got x2 on top and x4 on bottom. Where did my x end up at in my final answer?
On the bottom.
On the bottom. Okay, so I've got y5 on top and y2 on bottom. Where do my y's end up in the final answer? On top. Okay, and then my z's is a 1 and a 7, and where do my z's end up? On bottom. So what do you notice about where they ended up? Okay, they split places but one. Which one is bigger of the 5 and the 10? The 10. Which one is bigger of the 2 and the 4?
Oh, the biggest went to the bottom of the.
Which one is bigger of the 5 and the 2? Which one's bigger of the 1 and the 7?
7, I think.
Okay, so which ones ended up in bottom and which ones ended up on top? Put your phone away. Okay, so what did y'all say? So how did we end up with these on bottom? How do we choose which ones were on bottom here?
The larger one?
The larger one, the one with the larger exponent, right? We still divided here. We could still say 10 divided by 5, even though it's really 5 divided by 10. But 10 divided by 5 is why there's a 2 in the bottom, because 10 was larger. So it ends up on the bottom. X4 is larger than x squared. So there were 2 x's left on the bottom. Because remember when we simplify, guys? Okay, when we have the same thing on the top and the bottom when we're dividing, they cancel each other out, right? So this x from my x squared would cancel with 1x on bottom, and this x would cancel with another x on bottom. So am I left with any x's on top? No, but how many x's am I left with on bottom? 2. So that's why I have this x squared here. Okay, so why did some end up on the top and some end up on the bottom? So the variables end up on side with larger exponent. Okay. The variables end up on the side with a larger exponent. So now look at what we answered up here in A and B, and let's write a rule. Okay? Write a rule for how you would deal with multiplying exponents. So the pattern that you recognized up here in the top is the same pattern that always works. So how can we turn it into a rule?
Now, what happened to C? What? Oh, there it is. My fault.
So we're creating a rule for multiplying with exponents. Okay. So what are we going to do with the coefficients? So you multiply coefficients and add exponents. All right, so what would the rule be when you're dividing with exponents? What do you do to the coefficients? Divide coefficients and do what to the?
Subtract.
And subtract the exponents. for this next question, we need to refer back to these little, the little ladders that we made here. And we need to hurry up and finish our lesson here because y'all got to come in and get started on stuff, guys. Okay, so when they asked us to multiply, right, when they asked us to multiply, okay, again, we're talking about things with exponents. Okay, when they asked us to multiply,
So we added.
well, so we went down a notch and added. When we were asked to multiply exponents, we went down a notch and added.
Down a notch.
Okay, so if we're multiplying exponents, then we're going to go down a notch and we're going to add the exponents. Okay? So if we're being asked to divide, things with exponents, what are we going to do?
So we went up a notch and we went down a notch and subtracted.
Yep, we went down a notch both times and subtracted. Okay. So when you're doing operations with exponents, the exponents go down a notch. You actually apply the operation that's one less on our ladder run here. Okay. Do coefficients have any special treatment? Coefficients don't have any special treatment. Okay. Coefficients don't have any special treatment. They just do whatever they're being asked to do. So now, at the top of the next page, we are not actually working these problems out. We're not working these problems out just yet. We are just predicting what we are going to do with the coefficients and the exponents. So for the coefficients, if I'm multiplying, what am I going to do with my coefficients?
Divide? No, wait. Yeah, divided.
My coefficients
Or multiplied.
actually get multiplied. What happens to my exponents, though?
They get divided? They add.
My exponents add. Okay, when I'm dividing, what happens to my coefficients?
Divided. They're
My
divided.
coefficients get divided. What happens to my exponents?
Subtracted.
Okay, another division problem. What happens to my coefficients? My coefficients divide and my exponents subtract. And I'm multiplying on this one. Multiply my coefficients and add my exponents. So on top of the Get More Math assignment, I guess you guys need to finish this part of your notes on your own because we don't have time in class to for y'all to do them and for us to check them as a class. So I will check these and look at them at the beginning of class tomorrow. And okay, and then you do have Get More Math. For those of you that are new students, okay, and those of you that are new students, okay, my online students should have paused for a moment and worked these problems out. We've got 2 times 4, which is 8. My x's, you're going to add 2 plus 3, which is 5. And my y is squared. There's no other y's to combine with that. Okay, then here, 21 divided by 7 is 3. 18 minus 11 gives me 7. And 5 minus 3 on my E gives me 2. Notice that these were all bigger in the top, so my numbers are in the top. I don't need a fraction bar. Okay, this third one, I've got 1 and negative 1. I'm going to put that negative out front. Okay, and then 5 minus 2, so my A is in the top. Okay, 5 and 3, so my B is also in the top. And C, 5 and C4, so C1 is left, and it's also in the top, so no fraction bar there either. Okay. Then we've got multiplication here. Negative 8 times negative 7 is a positive 56. F6 and F2 makes it F8. G1 and G5 is G6, and then H. Okay. So now finish your conclusion, and at the end of the week, I will be expecting to get pictures of your notes and stuff. You're welcome to send them to me every day if you want, but I do need notes of your pictures of your notes for this week for the end of the week grade over notes. And there is a Get More Math assignment for you, 6 questions. Get it completed.